Hello guys, so this is a continuation of my last video, so where I left. So let me just restart again. So yeah, as per my last video, I tried creating some lag data, and I was using partition 9 for my training set. So yeah, uh, let's continue from that. Okay. Uh, this thing. I don't need. Actually, I can skip this run, but yeah. And this was about the choosing the partition. I don't want this to run again. I already got the plots. Yeah, I was selecting this partition 9. Okay. And yeah, here I created my lag data set. Okay. And this was, yeah, this part was my nemesis. So where it took a very long time. So instead of this, so my earlier attempt, I tried using left join, but it didn't happen. So on this part, I have to do something better here. So yeah, let's do. Join method is similar to merge function in terms of parameter operation, but the biggest difference is that the between two is that join combines data frame based on indices, while merge merges on both indices or columns. Okay, let's try with merge. Okay, how I want left, then on. I need date ID, time ID. I don't, okay, I only need symbol ID. Okay, and anything else? Okay, so this two, left on, right on, these are traces. Anything else I need? Okay. Uh, this I have, and yeah, I only need data group by, and from that I only need date ID, symbol ID, and responder 6, lag 1. Okay. local variable data df reference before assignment. Here I have created this. I have access to data df, right? Yep, it's there. So just need to time it. Why this? Okay. Let's- Oh, nice. Uh, yeah. This is what I'm expecting also, this amount of speed, because these are all vectors, right? So vector concatenation should be faster rather than iterative process. Yeah. Okay. So I'm getting some nan values, and I'm getting this thing. Okay. So yeah, for all 1530 it will be nan. So as I have explained it here, yeah, this will look something like this. Okay. And one more thing is, so I'm using a tree based algorithm, so this should be fine. Okay. So do I need to fill nan? I will only use tree based algorithm, so I don't actually need this. Mm, what should I call? Column and null count. This is how you change it, right? Ah, okay. Okay. I need to see all the rows, but yeah, it's somehow not showing me that. Okay, anyways. So for this, I have many null values. Okay, cool. Let's not do this. Let's have the nan values. Okay, and yeah, here let's split our training and validation set. Okay, so around 4 million rows are falling into my training set, and around 2 millions are in my validation set. Okay. Let's quickly see the distribution of my responders. So train data will look something like this. For my label, which is my responder 6, let's look at the histogram. Okay, and solid distribution of train of label in train set. Val data. Okay, both look couple of uh, identical, but the only issue I'm seeing it here is I have some -5 here, and I have pretty less values here. Okay. So instead of doing this, let's create folds. So data k fold. Let's do 3 folds. So this will take my create fold function. Okay, so here I will pass my data df, and here I will mention my target column is uh, responder 6, and the number of splits I want from this is 3, let's say, and bins this can decide, but yeah, it should be 10, because the values are varying between -5 to 5, so I have 10 buckets, so I'm putting this as 10. Okay, now after this, so I will call my train data to kfold to, so yeah, as per my function it should give me a column that's called kfold. Okay, and I will basically take all the rows where kfold is not equal to 0, and for my valid data I will take all the uh, rows that are for that has value that has k-fold value of 0. Okay, let's do this. Stratify k-fold is not defined. Okay, so let's go model selection stratified. I remember this is the one. Okay, anything else I need? I have pandas, enumerate, and yeah, okay, this should be sufficient. Yeah, okay, merged it, and yeah, let's run this. Okay, stratified k-fold is not defined. I just imported it, right? Interesting. Helper function. Stratified k-fold. Oh, okay. I have written stratified. Okay, and since it was a function, it was not throwing me an error. Yeah. Now you should work. Okay, still some error. Okay. It's not this one. This. It takes n splits. Okay. N splits, and random state it is also taking. So I can make. So since shuffling is false, so random state doesn't make any sense. So yeah. Oh, sorry. It takes n splits. Okay. It should divide them into buckets, and okay. Everything fall into my training data. Okay, something is wrong. Okay, initially I got kfold. I am doing certified kfold, that is SKF. Then bins, defined by struct rule. Okay, I'm cutting them with respect to my bins. Okay, let's not use this. Okay, then I will have three splits. Okay, drain this. I got df. Okay, and it's bin values, train idx. Hmm. Yeah, this is the thing, right? N is not defined. Oh yeah. N should be len of my df dot uh call. I can directly use an unique, and yeah, it's a function call. Ooh, so many errors. Okay, series object doesn't have this. Hmm. So, okay, but n unique is the one, right? Oh, okay. Unique. Okay. Hmm. What's happening? Oh, is it because my kfold is not setting? Ah, I got kfold. Oh, this is. Let's look at certified kfold documentation. This is my train IDX. Hmm. Okay. So I got two splits. Now this will split my data. This is my train IDX. Okay. Hmm. look at this. Yeah, here it has mentioned 10. Okay. I think it's something has to do with lock, because here I'm assigning everything. Yes, 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 makes sense. So this should hold my validation index, and I should call this lock. Yeah, now this should work. Okay, cool. I got the thing. Now I will have 3 splits. Okay, now let's look at the distribution now. Okay. Now you can see I have similar distribution between my train and validation set. Now they are good to go for training. Okay. Date ID, time ID. Okay, and I'm not considering the date ID and time IDs. I'm only considering the lags data. Okay. Now let's look at this. Okay, index weights are in not in column. Let's look at, oh yeah, these are weight, val weights. Yeah, this is val data, and feature calls. Yeah, feature calls. Okay, typo mistakes. Okay, I can see my train weights. Okay, they are good. And let's look at my train labels. Okay, these are good. Okay, now modeling. So I'm considering this. I can also consider this thing, but yeah, let's go with one thing first. Okay, now let's fit this. Okay, config has no attribute seed. Haven't I set the seed? Okay, yeah, I haven't set the seed. So pretty standard, seed 42. Then I should write set seed int takes int by default 42, and it does just sets everything, does not return anything. So helper function to set the seed for reproducibility. Okay, got this. So I can set seed for numpy. Why this? I don't know. I don't need this suggestion. I also need random. Okay, I got this. Now this one environment and Python seed. So I guess was that hash seed? Yeah, it's Python hash seed. Yeah, I will set this also to, and it takes a string value, right? Yeah, cool. And I'm not doing anything. This print statement. Seeding is done with seed, and let's call this seed function. NumPy has no attribute. Random. Ah, yeah, it's random dot seed. Okay, seeding is done, and I have set in the config. Yeah, let's navigate, and yeah, these should be good to go. Cool, and I got this, and I guess it would be better if I use GPU. It will be much more faster, and because I don't know whether it is even using that or not, so don't know how it will take, how long it will take. Hmm. RAM is increasing. We are already in 19 gigs. Hmm. Interesting. I think this will take a while. Oh, cool. I got this result. Now let's look at training R2 score. I'm not sure whether I should use this because so usually weighted R2 score looks something like this. So you have ground truth here and you have your prediction here, and then when you sum them up, and you have a normalization parameter here, but here you also do a mean of this, or instead I can do this. Okay, yeah, so this is the generalized form because it's stabilizes the R2 score, but here in this competition they are not considering this. Okay, and in this competition, if we look at this metric overview, yeah, they are not considering this. Yeah, obviously 1 minus here. So not sure whether the auto score that I will get from the sklearn's library that is aligning with the one like aligning with the competition one, but yeah, let's see. I have already done this. I can run this. So reg pred, and I'll say train features, train, here is go train, here go train, and here go train. Okay, I got train R2 score, and I can modify this with validation R2 score. Let's run this. Okay, I'm getting this 0.0144. That's training, which is not that good and not that bad. On validation, I'm getting a -1, so which is worse. Interesting. But yeah, okay. So I can log this as well as in model param. I should hold this also. Okay. Yeah, I should get this. Let's try to fit another model. So let's call this XGBoost. Now let's try RandomForest. Okay. So for RandomForest, I can let's look at RandomForest. Random for a regressor. Right now I'm not focused on how many I need. I will just do, yeah, I will just do them as it is. So I need some starter. Yeah, I need this thing. Okay, right now I'm not focused on this. This thing I need config. What should I call? So seed max features. This. let's keep it really simple. Let's make it 200, and here let's check out the same, like let's do the same parameters. Criterion absolute error, yeah. Max depth 3, and have I used anything else? Learning rate, tree, method, val, metric. Yeah, I don't need this. Okay, so I'll simply call this, and does its fit method take weights? Yeah, it also take weights. Cool. Yeah. Train weights, train weights. Let's do the same thing after this. Okay, and okay. Train output score, val output score. Okay, let's run this. The history saving thread hit an unexpected error. Attempt to write to a read-only database. History will not be written to the database. Okay, let's look at another model. If it Tanash, another I can try light GBM. Let it finish. It's taking a while. So this should be like GBM regressor. Yep. Yeah. Okay. Yeah, it's got C. Objective. Yep, I can pass the objective, same as this, and an estimators. I again fit this model. Shit. Mistake. Okay. Does not accept missing values encoded as natively. For supervised, you might want to consider sklearn hist gradient boosting algorithm and regression which accept missing values encoded as natively. Alternatively, it is possible to process the data. Okay. Okay. RandomForest doesn't take nan values. Boosting algorithm takes. Okay. Okay. I can fill in the nan values, but then they look something like this. Here this guy didn't pass anything. None. X is this. Not none here, and there he pushed this value. Okay, so I can use this. So what I can do is my labels doesn't contain any nan values, and must be 1D or scalar. Okay, how do my train weights look? Yeah. Um, this should be 1D, right? Okay, labels are looking good. This thing, this is something I need to take care of. Okay, if I simply do values, okay, they should be in 1D. Okay, so about this. Yeah, I got squeeze, right? Can use NP squeeze. Work. So this will go here. This will. Okay, yeah, I need to stop this. I don't want to fill this. I want to fill this with zeros. I can't stop this. This is also a good value so that they can separate out things. But okay. Okay, let's stick to this. It's just help the underlying decision tree to whenever they are making splits for decisions. So uh, larger negative values which are like kind of outliers with respect to the overall training values. So it helped them to not use those values for making prediction. So this kind of thing also helps during training. Okay, I got this. I need to use squeeze. Squeeze here, squeeze here. This will be val weights. Okay. Okay, and one more model I need is this one. Have they given any example? Nope, they have not. Okay, RAM is increasing. Okay, let's complete our LightGBM code. So LightGBM. So LGBM. Okay, and once I import this, so LGBM model, so here I need to make this thing. So yeah, LightGBM regressor, LGBM, LGBM dot LGBM regressor, and okay, this will take some time. Okay, I need estimators and boosting types I need. So this should be my GBT, gradient boosting trees, and max depth. Max depth I should limit it to 3. Then, so right now all these parameters are like, no, I'm not experimenting with them. I will experiment with them if when I'm doing a grid search. I just need a quick comparison between the algorithm. Okay, and yeah, random state also. Config seed, anything else, and yeah, metric I need, right? L2 is basically mean square, right? Lasso. L2 regularization. This should, yeah, yeah, these are basically square, so I can use L2 directly. Okay, these are the names, right? Okay, this is taking now long time. Okay, like I told you, like this sklearn library, they are pretty slow. So as you can see, like the native XGBoost library is pretty fast. It trained in like within 1 or 2 minutes, but this is taking long time. Okay, I've initialized this. Then I need yeah, this thing, so they can handle nan values. So let's do this. I need my LGBM model to fit this, and I will calculate this. So let's look at their predict. Okay, doesn't have a predict. Yeah. I should use GPU. Yeah. Okay. Predict. I need dot predict. Where is that dot predict? But okay. Is it done? Still loading. Okay. I should not use this. I should use this. LightGBM. Predict, and then this value. Train out to score, and the next thing I need is this. Okay, and I need something like this. Rain auto score. Okay, cool. This is taking a long time. It doesn't stop, it just runs. Hmm. Uh, okay, this is taking a long time. Hmm. It's because I've not given the jobs. You shouldn't have to use thousands of trees to build a model. Once your model begins to converge, adding more trees won't necessarily worsen the model, but at the same time, it won't add any new information. Okay, makes sense. By avoiding using too many trees, you may be able to cut down a calculation which would have taken on the order of a week to less than a day. Okay. If on top of this you leverage a dozen of CPU cores, then you might be looking at something on the order of hours. To look at variable importance after each random forest run, you can try something along the lines of the following. Okay. But this is given in R. I will be using a grid search, but this is just taking too long time. Okay. So far, uh, this was not really good. So this means like my XGBoost is just randomly predicting values. I should also plot this. Um, let's create a function plot prediction. Yeah, so takes white spread, white true. Yeah, so ELD figure, let's take fixed size and let's say we also get the title. Okay, let's make the fixed size to 15.7. Okay, and I need scatter plot. Let's look at SNS line plot. Uh, got data and this. I just need two lists and this. I just want to plot them. I need to give two things. Okay. So it's taking so long. Okay. It should be SNS line plot. Okay, and I can give ResTF. I'll be creating ResTF. It will take X, and I'll be providing two Y's, right? How will I provide two Y's? Multi-lines. Okay, just give the X thing and are you good to go? Okay. I only need this thing. So here I will pass ResTF, here I will pass index, and here I will pass value, and here I will pass variable. Okay. So with respect to this, it will plot everything, I guess. Okay. Okay. Then PLT title will show me the titles, and PLT dot plot. So okay. So this I can make it here. And this, then prediction, widespread, white labels, and widespreads. Okay. Similarly here, and plot this, and title. I can give XGB model. RF model. And GB model fit, GB model this, GB model this. LGBM models. Okay, taking long time. I want to cancel this. It doesn't cancel also. I don't want to restart. I guess I have to restart. Okay, I know which cells I need. Yeah, okay. Don't need this. Don't need this. I need you. I need you. I need you. I need you. Cool. Okay, cool. I want to reduce this to 100 and I want to increase this by 4. And let's try with mean square error. Okay. I can also use a folded wise prediction, but yeah, these are all the things I can do. Just need time and patience. Thirteen gigs. Okay. Let's look at a couple of discussions. TensorFlow very slow. Okay. Let's look at recently posted. Oh, it's done. Cool. See, it's so fast. Earlier also I was getting something similar score. This is less random. RESTDF. Ah, I forgot to create RESTDF. Yeah, RESTDF should be pd dot data frame, and this should be tuple zip, and I need d for lean range of y true, and I need y true, and I need y pride. Okay, d for d in. Only integer scalar arrays can be converted to a scalar index. Ah, len. Could not interpret index. Ah, yeah, I have to pass columns also. Okay, columns are my index. Then I'm giving y true. Then I'm giving y prime. Multi-line plot, right? Do this. I simply give this. Oh, I should remove. Okay, I should remove index. Okay, I don't need index. I don't need index, and I simply need to give it like this. It's only giving me Vibrad. This guy is getting multiple line plot. Is there something wrong with my Vibrad? Val threads. Okay, these are like this. Then val labels, these are like this. Is it because of this? and clip out the values so that it will be always between -5 to 5. Ah, okay. Not looking that great. So I'm very much limited to -2 to 2. Okay. Okay, Random Forest, I will not run you. Mm, I will run you later. Yeah. But yeah, I forgot to put the estimators. And estimators. Yeah, they should be same as my XGBoost. Okay. Alias. No modular LGBM. Solution guide. Once I install this. Okay. Go to quick start. I thought uh, Kaggle has this. Let's look at train. Okay. Installation guide. There's something wrong with my naming. Oh, LightGBM, and then you can import this. Okay, cool. Sample weight must be 1 DRR. Okay, it's complaining as random forest. So so train weights, train labels. Yep. Unknown boosting time GBT. It was GBT, right? Boost GBDT. Okay. T GB decision trees. Gradient boosting decision trees. Okay. I'm hoping like this should be fast. No further splits with positive gain, best gain minus infinity. It has only used 80 features. Okay. Maybe my learning rate is a little high. Okay, just keep on piling. Okay, finally it stopped. Okay, let's do the prediction. Okay, it's kind of worse than my XGBoost. Yeah. Okay. Hmm. So in this experiment, what I have done is I have used the lag data, right? And I have taken the mean of it. Yeah. The plots look similar to my XGBoost. Yeah, but I have some fitting over here. Yes. Okay, I think I'll be needing a couple of more feature engineering. And I need to increase my dataset because I have only taken 168 days of data. And yeah, I have taken all 9 values. So let's take notes. So experiment. Okay, so first thing, hmm, lag data by 1 day. Okay, then partition 9 I have only taken. Partition 9 is also only taken. Okay, and I have used one fold only of the partition training. Okay, and XGBoost is showing better results than LGBM. Okay, with an estimators 200 and max depth of 3, because if I remember XGBoost was giving me some minus 0.48 R2 score, whereas this LightGBM is giving a little worse, my minus 0.89. So yeah. Okay, then yeah, other take on is yeah, RandomForest is taking very long time for training. Yeah, I should also mark the result. LGB results, and okay, this is the result. And similarly for exposure chapter. Yep. I'll take this. I'll take this. And make this. So this is just for my experimental logging. I don't want to use any external service, so I'll just use this in the notebook for further clearing, for further analysis. Okay, let's paste this, and here my train and var to score. Okay, and here okay, cool. So yeah, I need more feature engineering on this. I can try with that time ID and data ID, that sinusoidal curve, and I can take more data. Okay, and yeah, some normalization has to be performed, some kind of over the features. So yeah, so I hope you guys learned something new, and I hope this videos like that I'm creating for this competition are giving you some insight, like how to progress in this competition and what models to take. Okay, I hope I'm helping in that aspect. So yeah, cool. Thanks for watching, guys. Just stay tuned for more videos on this competition.